Good morning students and welcome to our YouTube channel Gnan Manjari Modern School. In previous 2 lectures we have started the new chapter, that was lesson number 11, that was pressure. Okay students, and in this we have seen that what is pressure. Pressure is force per unit area, that is pressure. In that case we have seen, first of all, what is pressure. Pressure is force per unit area. Okay students, and in the introduction we have seen the two case. In that case we have seen the one. In the first case we have seen in the leg with this type of heel shoes. Okay students, and in the next case we have seen with sharp so we have seen this both case, and here we put the same force. Here will be same force in both case, same force in both case. Okay students, but here is different in area. Force is applied the same, but the area is different. So here the area is this much, and here the area is this much. So from this, which is the small one? This is the area will be small one. So here P is equal to F upon A. Here the area is less or small, so area is small. So as the denominator is small, the answer will be high. So here the pressure is high. In this case this shoe will hurt us, and let's see the another case. In this case P is equal to F upon A. In this case the area is big, means area is big. If the denominator is big, the answer will be less. Okay students, the pressure value will be less. So this will not hurt us. Why? Because here the area is more, and here it will hurt because the area is small. We have seen that pressure is direct. If the force is same, the pressure is inversely proportional to the area. Okay students, we have seen in previous video. In previous video I have given you homework of 2 examples. Have you calculated? Let's calculate that 2 example before starting the new topic. So in the first case, question number 1, that was in question number 1, the pressure has been given, that was 30,000 Pascal, and in that case the area was given, area was 4 centimeter square. In question number 2, question number 2, the pressure was the same, P is equal to 30,000 Pascal. Okay students, and in this case the force was given, the force was 12 Newton. Okay students, so these two examples I have given you in previous video. Let us calculate that. Here the pressure value is 30,000 Pascal, and here also the pressure value is 30,000 Pascal. So here area is 4 centimeter square, and in this case force is 12 Newton. Okay students, so first of all what we have to do, area is converted from centimeter square to meter square. So 4 centimeter square, 4 centimeter square is equal to 4 divided by how much? Have you calculated these sums? 1, 2, 3, 4. 4 zeros means 10,000, that is meter square. So what will be the answer? 0.0004 meter square. Okay students, so this we have get the area in meter square. Okay students, now we will put the area. What we have to do? First of all, pressure is equal to force upon area, but here pressure is given and area is given. What we have to do? We have to calculate the force. So we have to make force for subject of formula. So F is equal to P into A. Okay students, have you understand this? So what is the value of pressure? The value of pressure, that is 30,000 Pascal into, what is the value of area? That is 0.0004 meter square. So here we will calculate. So the answer will be 4 3s are 12 Newton. Okay students, here the answer is 12 Newton. Please note down this example. So have you written this students? What will be the answer? That is 12 Newton. So this is your question number 1. Now we will calculate is question number 2. In this, what we have to do? It is already in Newton, so we don't have to change the value. Here pressure is equal to F upon A. In this case we have to calculate the area. So we have to make area the subject of formula. So A is equal to, A will come here and P will go down, that is F upon P. Okay, let's put the value. Here the force value is 12 Newton and the pressure is 30,000 Pascals. Okay students, so let us calculate. Here 3 4s are 12 and the answer will be 0.0004 meter square. Okay, area, answer of area will become in meter square, and the area of force, the answer of force will come in Newton and area will come in meter square. Okay students, what I have just do is, we have get the same area that was here. You can see I have given, in this case I have not given the force, and in this case I have not given the area, but the answer was same. The area was 0.004 meter square, and here the area was the same. Okay students, and here the force was 12 Newton, and here also you can see that the force is 12 Newton. I have just in this case not given the force, and in this case I have not given the area. So you have to calculate this. Please note down this. Now, we will start with our new topic, that is pressure in fluids. So, pressure in fluids. Pressure in fluids. So, let us see that as you already know, liquid and gases are collectively called fluids. An object present or immersed in a fluid experience pressure in all the direction. So first of all, here it is given pressures of air and gases. Here is one activity to show that gas exerts pressure. Material needed, a rubber balloon. Okay, we need a balloon. Method: blow air into the rubber balloon. You will see that the balloon expands. Keep blowing air into the balloon will expand further. Continue to blow. What do you observe? We have to take one balloon and we have to expand that, fill the air in balloon and make it bigger and bigger. And at last what will happen? We have to see observation. When air is blown into the balloon, the pressure of the air inside the balloon pushes the material of the balloon and makes it expand. As more air is blown, the balloon expands further till a point when the material of the balloon cannot stretch any further without breaking. As more and more air is blown into the balloon, a point is reached when it can expand no further and the balloon bursts. The same happens when any gas used to fill in the balloon. Conclusion: gases exerts pressure on the wall of the container that holds them. Okay students, so in this we have seen we have to take one balloon and we have to make the balloon bigger and bigger by filling the air in it. As the air is filled in, it will expand. First, when you fill the air, it will be small, and then if you add some more air, it will be expand more, and after it will expand more again and again. If you fill the air inside the balloon will expand. At one position, when the balloon is stretched at its end level, if you also fill the air inside, then also fill the air, it will burst. the balloon will be burst. Why? Because the material which is used for balloon has some capacity to hold pressure of that air. So if we add more and more air, the pressure in the balloon will increase, and at certain stage the balloon will be burst. Okay students, so in that activity we have seen this. You can also try this activity at your home. Next, atmospheric pressure. We have just learned that air and all gases exert pressure. If air exerts pressure, what about the sea of air that we are living in? Does our atmosphere exert a pressure on us? Let us find out. So, for atmospheric pressure, what is first of all atmospheric pressure? The pressure which is in the atmosphere, that is atmospheric pressure, and just we will find how it acts. Here is an activity to show the presence of atmospheric pressure. Here is an activity to show that there is an atmospheric pressure on us. Material needed: a glass tumbler with a smooth rim, a piece of cardboard big enough to cover the mouth of the tumbler, and water. Okay. Method: perform this activity over a sink or wash basin. Fill the water in the glass tumbler up to the brim. Place the piece of cardboard in such a way that it completely covers the mouth of the tumbler. Press down the cardboard piece with your hand as we shown in figure, and quickly up the tumbler. Gently remove your hand, pressing the cardboard piece. What do you see? In this activity, what we have to do? You have to take a tumbler, and in tumbler you have to fill the water. After filling the water, you have to just covered with cardboard which covers whole the mouth of the tumbler. At once you have to turn the glass and slightly remove your hand from that pressed cardboard, and what you will observe? Let's see that what we will observe. You will see that the cardboard does not fall off and the water does not spill, even though the tumbler is turned upside down. Conclusion: the pressure of the atmosphere exerts enough force on the cardboard so that it is able to hold up a tumbler full of water. What will happen? Here we can see that this cardboard will not fall down, or in the tumbler the water is there, that also will not come out, and the cardboard will not fall down. So here we can see that there is an atmospheric pressure on the cardboard, so which helps to the tumbler which is inverse, and it helps to keep that. Okay students, so in this activity we have seen you can also do this activity at your home, but you have to do this activity near your sink area. Okay students, don't do anywhere in the home, you have to do this activity at your sink place only. And next, in your book, that is here the activity, again there is an activity to show the presence of atmospheric pressure. Okay. Material needed: a rubber sucker and a smooth and flat stainless steel ceramic plate. Here we can see that press the rubber sucker on the surface of the plate and leave it. You will see that the rubber sucker holds onto the plate. Make sure that you have pressed sucker downward quietly well and it does not move when you shake it. turn the plate to the its side, hold up upside down or any way you want. The rubber sucker still holds firmly on the to the plate. We all know the rubber sucker come. In that what will happen? If you put a rubber sucker here and press it and take it off, then it will stay here only. Due to the atmospheric pressure it will stay here only. If also you can उसमें कुछ आप टंगोगे तो भी वो वहीं रहेगा. That will not come out of it. So due to this atmospheric, due to which pressure, this is atmospheric pressure, this will not come out. In this activity is observation and discussion. Examine the rubber sucker closely. It is made of a flexible rubbery material. It does not contain glue or any other sticky substance. Then how does it stick to the plate? The action of pressing the rubber sucker to the plate pushes out most of the air in the space between the rubber sucker and the plate, creating a partial vacuum. Atmospheric pressure presses the rubber sucker to the wall, but since there is nearly no air in the space between them, the rubber sucker remains stuck to the wall. Further, observe that you can hang objects on the hook of the rubber sucker and it still holds on the wall as seen in figure number C. Conclusion: air in the atmosphere presses the rubber sucker in all direction. Okay students, so in this activity we have seen that we need an rubber sucker which is put in a plate and press tightly and take out the hand. We can also put anything on that, it will not come out. If we want to come out, we have to make more pressure than the atmospheric pressure. So these will come out of the wall or any plate. Okay students, so this is the some of the activities. Okay, let's see what is next. So next, in the above two activities, we have observed that we are living in a sea of air and the pressure of air presses us from all sides. One of the main reasons why the earth has an atmosphere is it is gravity. The gravity of the earth pulls the air molecule and keeps them bound to the earth. Therefore, the force of gravity on an object is its weight. Therefore, the air around us actually has a weight. The weight of the air is in the atmosphere presses every object immersed in it and produces a pressure called atmospheric pressure. Okay students, so there is an air around us. If we are standing here, the air is all around us. If we are standing in a normal day with normal weather, we will not, due to air, we will not move. But if there is lots of wind and air, the weather is not good. If you are standing there, you can't stand. You will, due to air force, you will go back and back. Okay students, so this is atmospheric pressure. Atmospheric pressure is defined as the pressure exerted on an object by the weight of the air above it. So what is atmospheric pressure? Atmospheric pressure is defined as the exerted on an object by the weight of air above it. So, here is the atmospheric definition, that the atmospheric pressure is defined as the air exerted on an object by the weight of the air above it. As the pressure exerted on an object by the weight of the air above it. Okay students, what is atmospheric pressure? Atmospheric pressure is defined as the pressure exerted on an object by the weight of the air above it. Okay students, we have seen this. Now further we will see in our next video. Please write down your today's homework. Your today's homework is please write down your today's homework. Question 1, that is, what is pressure? Give its SI unit. Okay students, next question, that is question number 2. Why does a balloon burst if too much air is blown into it? Question number 3, that is, define atmospheric pressure. Okay students, so you have to define the atmospheric pressure. These are the 3 questions of your homework. Question number 1, that is, what is pressure? Give its SI unit. Question number 2, why does a balloon burst if too much air is blown into it? This answer is there in your activity, first activity which we have seen in this lecture. We are blowing a balloon, after at certain stage the balloon will burst. So you have to write down why a balloon bursts if too much air is blown into it. Okay students, this answer, question number 2's answer will be in your activity. Question number 3, define atmospheric pressure. You have to define atmospheric pressure. Okay students, up till then, so this is your today's homework. Up till then, stay safe, stay home. Okay, bye students.